The
Transverse wave, super Mari. So entire concept is zero. Your nothing you remember. Okay, super. So sound waves are what waves, Amma? Longitudinal waves or transverse waves? First, longitudinal waves. So longitudinal waves means they will travel in a medium. How? Longitudinal waves will produce in the what? There is a two words in longitudinal waves. What they will produce?
compression and rarefaction.
Compression and
Compression
rarefaction.
and rarefaction. That's what you're saying. Transverse wave, Mari. That's see that. So they are asking question: how does the sound produced by a vibrating object in a medium reaches your ear? How it will be reaches? Till here you have to write it. The sound. Start writing answer separately in the class. The sound produced by a vibrating object in a medium reaches your ear. Reaches our ear. Our ear. Our ear in the form of compressions and rarefactions. Compressions and rarefactions. That is only compression rarefactions means what is the name of the wave? Everybody answer response. Response write out from the meeting. No problem. For me 10 people also no issues. I want proper response. Make it everybody. So what is that? That is only we used to call it as longitudinal wave. One time, one answer also not giving in one class, not at all required, whomever it is. Next, second question. Explain how sound is produced by your school bell. How the sound will produce by your school bell? Yes, please.
Sir, are they asking about the mechanism?
Yeah, you have to write the mechanism of that. So school bell consists of what? Basically,
Electromagnet.
basically in the 8th class you all will study. So there will be a
Yes, sir.
gong. Yeah,
Electromagnetic
there is
bells.
a metal, that's what I'm saying. A metal one, which we used to call it as a gong actually. Gong, G-O-N-G, gong. In an arrangement which is connected with the external source of current. Current will be producing. And there is consist of a small hammer. You might be all remember our school bell also, you can see that. Am I right or wrong? So there will be a hammer like this, exactly. So current connections will be there. So whenever inside electromagnet, as Mari said, U-shaped electromagnet will be there. So whenever current passes, this hammer will come and it will hit this gong. So that is how it will produce the current sound. Now when this current passes through this arrangement, this small hammer will hit and the gong repeatedly causes to vibrate. So who is vibrating here? Who is vibrating? Gong will vibrate when the hammer will hit. So this vibration will travel in air in the form of what? Again, same answer. The vibrations of a gong will travel in the air in the form of what? Compression and rarefactions. That is what longitudinal wave and will reaches our ear, which we can hear it as a sound. So that is what you have to remember. So what you have to write it? So there is a setup of consist of what? Consists of what? A hammer and a gong. Do you understand? And there is connected to the external current, external source of current. So when the current passes through this arrangement, this small hammer will come and hit the gong so that the gong repeatedly causes to vibrate. So these vibrations will travel in the form of compressions and rarefactions, which reaches our ear when we hear the sound. That's what you have to remember. Clear, everybody? All of you? Yes? Next.
Yes, sir.
Why are sound waves called mechanical waves? This I already taught you. Why are sound waves are called it as mechanical waves? Notebook you can see. So I have given you the definition of mechanical waves. Can you tell me anybody mechanical waves means? I want answer from Alfin. Alfin will say. Alfin, you have written a classwork, you tell me. Mechanical waves. What is the definition of mechanical waves?
Sir, waves which need material, sir. Material use.
Material or medium?
Material medium, sir.
Yeah. So Alfin not written the definition. Alfin, very good, super. I'll check correct also. Everybody write it. So what is why sound waves are mechanical waves? Without medium, they cannot travel. Is it possible to travel without medium? No. So that's the reason they are called it as mechanical waves. Right. Sound propagates in the form of compressions and rarefactions. Sound propagates in the form of compressions and rarefactions. Compressions and rarefactions. Not writing, acting, don't attend the class. No problem. Whomever it is. It's for your purpose only, not for my purpose. And your parents are simply feeling burden is not at all going to good. At least minimum common sense you must have. 8th, 9th class you are studying, going to 10th class, no sincerity in work at all. Sound waves propagate in the form of compressions and rarefactions. Compressions and rarefactions. Mechanical waves. I have taught you 4 types of waves. Can you tell me anybody what is the 4 types of waves we studied? One is transverse waves. Another one is what? Yes, please.
Longitudinal waves.
Longitudinal waves. And third one is what? Mechanical waves. And fourth one is electromagnetic waves. Mechanical
Electromagnetic
waves
waves.
means I told you the definition. Waves which need
Material
material
medium.
medium for their propagation.
Material
Material medium for their propagation are called
connection.
mechanical waves. That is why mechanical waves may be a transverse waves or may be a longitudinal waves. We cannot say what is what. So both, whatever the waves need material medium for the propagation, they are called as mechanical waves. So we all know sound does not travel without medium. Sound cannot be propagate without medium. So that's why sound is a what? Mechanical wave. That's all. Write it. Compressions and rarefactions are formed. Compressions and rarefactions are formed. Compressions and rarefactions are formed in a material medium. In a material medium. In a material medium. Hence, sound waves are known as mechanical waves. Hence, sound waves are known as mechanical wave. Clear?
Yes, sir.
Mr. Gokul doing a Alfin, I call you, you don't understand? Are you writing or not, answering or not? Next question you only need to answer. No excuses for anything. Suppose you and your friend are on the moon, will you be able to hear any sound produced by your friend? That is what is the question. Answer please. Is it possible? Anybody?
Sir, no, sir. There
No,
is no
sir.
medium.
Yes.
Vacuum.
So sound cannot travel in vacuum. Sound cannot travel in vacuum. So in moon, what is happening? No material medium is present. Since no material medium is present, no material medium is present, no material medium is present, and where? On the moon. Hence, you will not able to hear. Hence, you will not able to hear. Not able to hear. Don't simply all like this only. I don't know why people. Any sound produced by our friend. Make it. Call to the Pranora. Hurry.
Sir, his mother is in GH's night shift, sir. So that he can't attend. Sir.
Lingesh, every day no need to say Lingesh. You know what is that? Am I right? Next. Next. Which wave property determines next one? Which wave property determines loudness and as well as pitch they are asking. So loudness means yallness. Loudness is determined by what? I have already taught you. Loudness is related to what? Everybody?
Amplitude.
Yes, please. Amplitude. Pitch is related to what?
Frequency.
Frequency. Next. Guess which sound has a higher pitch? Guitar or a car horn?
Car horn.
Really? Pitch. Pitch means frequency is higher, Mari.
Higher frequency, sir.
Yeah. So frequency of whom it is higher?
Guitar, sir.
Guitar. Right. The sound of a guitar has higher frequency, higher pitch because of its large frequency. Of its large frequency. Completed, everybody?
Yes.
Next. Water wavelength, frequency, time period, and amplitude of a sound wave. I hope you all knows. Anybody don't know? Everybody knows I have taught you. Am I right, everybody? Single
Yes,
wave,
sir.
you all can represent what is wavelength, what is frequency. So first frequency means what? Number of oscillations per how many seconds?
Second.
Yes.
Second.
Number of oscillations per 1 second. So that is what we used to call frequency. Wavelength means what? The successive distance between two, how many?
Crust or two
Either
of
two successive crust, the distance between two successive crust, or the distance between two successive trough
rough.
is called it as wavelength. Next, time period. What do you mean by time period, everybody? Time taken
Number
to
of
complete
oscillation in
time
a
per one wave. Time taken per complete how many waves?
one wave.
One wave
One
or
wave.
one oscillation is called it as time period. Amplitude means what, everybody? The
The height
maximum
of the
displacement of a wave from its what position?
mean position.
From its main position. That is what we used to call it as amplitude. So that's all. Next. Write it, everybody, revise everything. How are this coming week? Definitely, everybody need to show me the classwork and I'll make it everything. That's what remember, everybody. Simply making means no, I'm very, very serious. People are this much lethargic, people all are. How are the wavelength and frequency of a sound waves related to its speed? Anybody? Related to speed and wavelength. Formula, we know that. Speed and
Sir,
wavelength formula.
equal to wavelength into frequency.
Yes, very good.
Wavelength
So
into frequency.
wave speed is equals to wavelength into frequency. Am I right or wrong? Formula. Remember,
Yes, sir.
this is the symbol for what? Frequency or velocity or
Frequency.
frequency. Clear?
Frequency.
That's all it is. So wave speed is equals to wavelength into frequency. That's all. Because we all knows that frequency is equals to what, everybody? 1 by time period. Is it right or wrong? All of you? Yes. 1 by time period is equals to frequency. That is what it is. Next.
Yes, sir.
Calculate the wavelength of a sound wave whose frequency is 220 hertz and speed is 440 meter per second in a given medium. So what else is there? Wave speed they are asking. Oh, wavelength. So we all knows that wave speed is equals to wavelength into frequency. Now wavelength is equals to what? Wave speed divided by frequency. Wave speed is 440 meter per second divided by frequency is how much, guys? Yes, please. 220
20
hertz.
hertz.
So over 21s are 22s are. So wavelength is equals to how many meters?
2 meters.
2 meters. What is the unit of wavelength? Everybody. Unit of wavelength. SI unit of wavelength. Meters.
Meter.
Solve. Sangamitra is solving. Abhirami. Alfin. Niroshi. Next. A person is listening to a tone of 500 hertz. Means what is the frequency? Everybody. 500 hertz. Frequency is equals to 500 hertz. Hasini, are you solving, Hasini? Now, sitting at a distance of 450 meters. Distance is equals to how much, guys? Distance is equals to how much?
450 meters.
450 meters from the source of sound. What is the time interval between the successive compressions and as well from the source? Successive compressions from the source means it is a what actually?
So that is wavelength.
Compressions. Successive compressions. Time they are asking now. Time intervals between successive. That is what one wave. Am I right?
Yes, sir. It's time.
Yeah,
Time.
that is also time period. That's all. So
Yes, sir.
time period between two successive compressions is time period only. Time between two successive compressions is time period. So time period is equals to what is the formula? You know
1 by
frequency.
F.
1 by frequency. Frequency 1 by F will V. Frequency symbol changed, Amma. Padma. To understand frequency symbol is small v. Please remember everybody. So no F.
Yes, sir.
1 by 500. So 1 by 500 means what is that, everybody? 1 by 500. 0.0002 seconds. 0.002 seconds. Is it right? Everybody?
Yes, sir.
Solve it. Clear, everyone? 1 by 0.00 seconds. Clear? All of you? Is Darshan doing Gokul, Kishore?
Yes, sir.
Hmm.
Yes, sir.
I'll see that. Mr. Lingesh, are you there or not in meeting?
Yes.
Hmm. Next. This question you people don't know. You have to see that. Distinguish between loudness and intensity of sound. So these are the two things which we will speak in our daily life. So intensity of sound, you not hear that. So we can see that distinguish between loudness and intensity of sound. So loudness is the measure of the response of ear to the sound. How much response to your ear is actually the loudness. Loudness cannot be measured accurately Loudness depends on sensitivity of ear. It is not considered as a physical quantity purely. I will send you the differences, you learn it. Next, intensity. Intensity is physical quantity. It is measured per second per unit area and it is measured very accurately. It does not depend on the sensitivity of ear. So that is what is the differences between loudness and intensity. This question I will send you. You all should learn what is the differences between loudness and as well as intensity of sound. Okay. So that is what. Yes, Sanjay. Very good. So please remember this question. I will send you out to the class. Next. In which of the three media, air, water, and iron, does sound travel the fastest at a particular temperature? In which medium sound travel faster? Everybody, in a same temperature.
Iron.
Yes.
Iron.
A given temperature, in which medium it will travel faster? Everybody. We all knows that. In which medium sound
Solid.
travel faster? Solids.
Solid.
Then next one is what? Compared to solids, liquids less. And then least is what? Gases.
Yes.
That's why. So in which medium it will travel faster? Everybody. Iron. Do you understand everybody? So that is what. So sound travel fastest in which medium?
Solid iron.
Yes. So because what is the reason? Sound travel in which medium faster? Denser medium or rarer medium? It will travel faster in denser mediums. That's what you have to remember. Completed? Everyone?
Yes.
Next. Next one. This is a good question. You have to solve, everybody. An echo is heard in 3 seconds. What is the distance of the reflecting surface from the source? Given that the speed of the sound is 342 meter per second. Forget about it. Given data. The time, total time for echo, how many seconds? 3 seconds. Speed of a sound is 342 meter per second. Now I told you already, everything you forgot, only remember the formula. So calculating the distance. So what is the formula? First, speed is equals to 2d by t. Sorry, 2s by t. S means what? Everybody. S means what?
Distance.
Now S is equals to what? 2t, sorry, Vt by 2. That's all. Learn the formula, substitute the values, you'll get the answer. That's all. So Vt by 2. So what is the V, everybody? What is the V?
342.
342 into time is how much? 3 divided by 2. 2 ones are 2 ones are 2, 2 sevens are 2 ones are. So which is equals to 171 into 3, which is equals to how much? 513 meters.
513.
That is what. Yesterday I given one question. Laksha is not all getting answer. Just multiplying with the 3, Laksha. You will get the answer correct. You have to make it that. Yesterday I have given you numerical 2. Do you remember everybody? What is the first question answer? Homework question. V is equals to 340 meter per second will come. Have you got the answer, everybody? And the second question, 344 into 3 multiplying. How much is the answer? 1032 meters. That's all is the answer. Understand, Laksha? Yeah. Everybody clear? Anything doubt, please ask me. So this question have you solved, everybody? 513 meters. Understand? Diagram you draw. So reflecting surface. So if you take it, this is what is the person and this is the reflecting surface. You can take it like imagine mountain. Going distance is yes and coming distance is what? Again yes. So total distance is how much, Ra? Total distance is how much? 2s. And then the total time is given. Echo time. Echo time is how many seconds? 3 seconds, which is equals to V. So, sorry, velocity. So now from that, S is equals to V into time. Time is 3 seconds divided by 2. That's all. If you get it, you will get the answer. Understand, guys? Mr. Sam? Everybody clear? All of you?
Yes.
Then that's what. Solve it. Next. What are the ceilings of concert halls curved? Sorry, why are the ceilings of concert halls are curved? I already taught you this.
So that the echo will be avoided.
Yes, yes. So they are the good absorbent. Here it is there we are having concert halls ceiling. So where is that? Yeah. This is what? Not the echo will avoid and Mari. What is the reason? To make everybody's even sounds. The sounds produced by them will be reflected evenly to all the audience throughout the auditorium. That is the reason. Okay. So they are actually curved path. So it is like a what? Concave. What is that they are? They are like a concave. Okay. So after reflecting from the ceiling, it will spread evenly across the width of the hall and reaches to the audience in the hall. That is what is you have to write it. Clear, Mari? Yes? This is
Sir.
full paragraph. You can make it. Cinema halls so that the sound after reflection reaches all concerned corners of the hall as shown in the figure. Sometimes a curved soundboard may be placed behind the stage so that after reflecting from the soundboard spread evenly across the width of the hall. So soundboard and curved everything same because they are concave. Concave. Clear? They are concave. Understand? Yes?
Yes, sir.
Next, what is the audible range of average human ear? What is our audible range? Everybody.
20 hertz to 20 kilohertz.
Yes. 20 hertz to 20 hertz to
20 kilohertz.
20 kilohertz. That's all. Write it. Prithvi doing a Prithvi?
Yes, sir. 20 hertz to 20 kilohertz. Alfin, I called you till now 5 times, Alfin. No response even one time. Next, what is the range of frequencies associated with the infrasounds? Infrasounds means what, guys? Infrasound. Less
Below
than 20 hertz. Less than 20 hertz and greater than 0 hertz. Next, ultrasounds. What is ultrasounds? Frequencies greater than, yes, please.
20 kilohertz.
Yes, greater than 20 kilohertz. Okay, and up to 10 power 7 kilohertz. So note it. 10 power 7 kilohertz. Book also you can mention. Yes. Range of hearing 20 hertz ultrasounds. Yeah. The frequency higher than 20 kilohertz are called ultrasonic sounds or ultrasounds. Ultrasounds. I taught you yesterday's properians. Am I right? That fish, another kind of dolphins. Looks like a dolphins. 4 piece, yes.
Yes,
Am I
sir.
right? Yeah.
Yes.
Moths also. Moths of some families also remember. They also can have a very sensitivity hearing equipment. So these moths can hear the high frequencies uh, like squeaks of the bat and known when a bat is flying nearby and they are able to escape capture. So that's what. Rats also plays games by producing ultrasounds. This we can notice those who are agriculture, farming and all, or else villages, houses. This is a most common problem we can notice. Rats night time and all, they all will play by producing ultrasounds, most irritating sounds. You all maybe not experience it, but I'm having experiences with that. So many times in night time we can, like my home, my village, we can notice nighttime rats will start like here and there moving by producing ultrasounds. Most irritating sounds it is. We cannot even get a sleep properly. That's what. Learn everything that
So one
next.
doubt, sir.
Yeah.
Sir, ultrasound is more than 20 kilohertz and less than.
Ultrasound. It is
Yes, sir.
up to 10 power 7. Up to 10 power 7. That's just
Yes.
a range. It is not even required. You just remember greater than 20. That's greater than 20 kilohertz. Okay.
Yes, sir.
Understood.
Yes,
Next.
sir.
Okay. Next. So that's all is in-text questions. Every in-text question is important. All the points you have to go through that. Only two formulas for wave speed. So please learn. Wave speed is equals to, what is that everybody? Wavelength divided by time period, or wave speed is equals to wavelength into frequency. So that is what 1 by time period is equals to frequency. This is the symbol for frequency. This is the symbol for frequency. So please learn that. So whatever it is, what is the wave speed unit, everybody? Meter per second.
Meter per second.
That is what. Units, this, that and all, not the, don't know. Very, very important. Next, we are having ultrasound has many in medical and industrial applications. All the applications I have taught you. Am I right, everybody? No application is left. Every application I have taught you, you have to go through that and you have to learn it. Next, first question, exercises. All of you open. What is sound and how it is produced? What is a sound? Sound is a form of, everybody? Sound is a form of energy which is produced by what bodies?
Vibrate.
Vibrating
Vibrate.
bodies. Yes. Which is produced by vibrating bodies. Like example, what is that, anybody? First activity, I told you. Tuning fork. Understanding? Wires of a guitar. Wires of a guitar, etc. Every vibrating body will produce the what? Every vibrating body will produce the what? Every vibrating body will produce a sound. That's
Bass.
what you have to remember. Prardhana, Jai Krishna, we're all doing. Next,
Yes, sir.
with the help of a diagram, how compressions and rarefactions are produced in air near a source of sound. So with the help of a diagram, we have to do it. So with the help of a diagram means you all knows that. So what is the diagram? Anybody can tell? With the help of a diagram. Yes, please. Your book also it is there. Tuning for diagram. Exam, if they will ask, you have to do the diagram. If not, no mark will be given. So what is the diagram? Tuning fork with the help of this we have to do that one. So this is only the things how the sound is produced. So there is no related, yeah. This is what a vibrating object creating a series of compressions and as well as what rarefactions in the medium. So that is only the question and we have to draw this diagram. Compression followed by rarefaction, again compression followed by rarefaction neatly when the tuning fork is vibrating, or else you can draw this diagram also. This is also the same thing. A speaker, so a speaker's source of sound we will consider as a compression followed by rarefaction, compression followed by rarefaction, compression followed by rarefaction. So that is what pressure variation. See that wherever particles are closer, highly compression, pressure is high, temperature also high. Understand? And low pressure. Density is also high. Density and pressure. Density variations you can see. Density increases, decreases. Compression, high density. Rarefaction, low density. Compression, high density. Rarefaction, low density. That is what you have to remember. Is it okay, guys? Everybody? All of you? So they are asking, describe with the help of a diagram how compressions and rarefactions are produced in air near the source of a sound. So you can draw any one diagram, either speaker or you can draw tuning fork. Okay, understand everybody? Clear, all of you? So mark that. And you have to draw neatly in the exam. Next, why is sound wave are called longitudinal waves? What is the answer? Anybody? Single word you can say. Why sound waves are called it as long waves? Because they need what? How they will produce? They will produce it by compressions and followed by rarefactions. Am I right or wrong? That's why they are called it as a what? All of you. What we used to call? They are called it as longitudinal waves. So write it. So write everyone. When sound waves travel in a medium, in the form of compressions and rarefactions, in the form of compressions and rarefactions, then the particles of a medium vibrate